Alright, this is the second video, finding horizontal asymptotes the calculus way. You might like this a little bit better because it doesn't involve as much memory and analyzing the degrees, but again, it's your preference on how you figure out horizontal asymptotes, and you can choose your preference after this video. Alright, so the first thing is, we have to start off, we're talking about horizontal asymptotes the calculus way. Alright, the definition of a horizontal asymptote. The line y equals L is a horizontal asymptote of the graph of f if the limit of f of x as x approaches negative infinity is equal to L, or if the limit of f of x as x approaches infinity is L. So in other words, if you want to find a horizontal asymptote, you can find the limit, either choose to find the limit as you approach negative infinity or the limit as you approach infinity, and it will give you the asymptote. So let's take a look here. We'll start off here with number 1, f of x. So find the horizontal asymptote if there is one of each rational function. So f of x equals 4x plus 5 over 2x squared plus 1. All right, now just like from class, we're going to go ahead and find the limit. So for our first step, let's find the limit as x approaches infinity. All right, so the limit as x approaches infinity of 4x plus 5 over 2x squared plus 1. All right, well, it's an infinite limit, so we're going to use that technique where we divide all our terms by the term with the highest, or by the highest degree. So I see the highest degree is x squared, so I'm going to divide all the terms by x squared. So I'm going to take the 4x divided by x squared plus 5 over x squared all over 2x squared over x squared plus 1 over x squared. All right, now we got to start analyzing. Well, if I take x, if I keep increasing x and put in really, really big numbers, 5 over x squared is going to go to 0. Well, 1 over x squared is also going to go to 0. 4x over x squared is going to become 4 over x, and that's also going to go to 0. And then here, these x squareds are going to cancel, and I'm going to be left with 0 plus 0 over 2 plus 0, which is just 0 over 2, or 0. For limits, we're finding our y value. We found that our limit would be y equals 0. Or our horizontal asymptote is going to be 0. Connected back to the last video, the degree of the numerator was less than the degree of the denominator, so our asymptote is 0. All right, now let's do the next one. I have f of x equals 4x squared plus 5, and I have 2x squared plus 1. Same concept, let's find the limit as x approaches infinity. Of 4x squared plus 5 over 2x squared plus 1. All right, now let's look for the highest degree, that's x squared. I'm going to divide all the terms by x squared. All right, now we got to start analyzing. 5 over x squared is going to go to 0. 1 over x squared is going to go to 0 when we have really large numbers. All right, x squared over x squared is going to cancel out right here. X squared over x squared is going to cancel out right here. And I'm left with 4 over 2, or 2. So my horizontal asymptote is y equals 2. Or I see the degrees are equal, so I take the ratio of the leading coefficients, 4 over 2. All right, let's do our last one. We have f of x equals 4x cubed plus 5 over 2x squared plus 1. Look for the largest degree, that's 3 this time. I'm going to take the limit as x approaches infinity, and I'm going to divide of 4x cubed plus 5 over 2x squared plus 1. Divide all the terms by that highest degree. All right. So that equals plus 1 over. All right. Well, let's look now. So I end up getting 0 right here when you put in really large numbers. I'm going to get 0 right here. X squared over x cubed, all right, is going to also give you 0. And then this is going to give you 4. So I'm left with 4 over 0. That means that this limit doesn't exist. Like I don't have a value for this limit as x approaches infinity. Our limit doesn't exist. So thinking about that, that means that I'm going to have no horizontal asymptote. All right. Or if you look up here, the degree of the numerator was less than the degree, or was greater than the degree of the denominator, so we're going to have a slant asymptote like from the last video. All right. Here's 3 U-tries we're going to do. All right. We have first one. I got to write them down. F of x equals 5x plus 7x squared over 3x cubed plus 5. All right, I have f of x equals negative x minus 5x to the 5th over 3 plus 7x to the 5th. And then for part C, I have f of x equals x to the 4th minus 1 over x cubed plus x squared. All right, so go ahead, you can pause the video and go ahead and try finding the horizontal asymptotes, the same directions as before. All right, I'm going to get started. So let's start by finding the limit as x approaches infinity of 5x plus 7x squared over 3x cubed plus 5. Well, I see the highest degree is 3, so I'm going to divide all the terms by x cubed. So I have 5x over x cubed plus 7x squared over x cubed over 3x cubed over x cubed plus 5 over x cubed. All right, well, now I see that this is going to go to 0 because when you put in really big numbers, 5 divided by a really big number is 0. Well, this becomes x squared over x cubed is 7 over x. Well, that's also going to go to 0. Right here, this is going to become 5 over x squared. This is also going to go to 0. These cancel, and I'm left with 3. So I end up getting 0 over 3 or 0. So y equals 0 is our horizontal asymptote. All right, let's take a look at B. Well, let's find our limit as x approaches infinity. All right, so I have here. Let's go ahead and I'm going to divide by the highest degree. I see that highest degree is 5, so I have negative x over x to the 5th minus 5 over 5x to the 5th dash over x to the 5th, 3 over x to the 5th plus 7x to the 5th over x to the 5th. All right. Well, negative x over x to the 5th is going to go to 0 because the denominator has a way higher degree. All right. this right here, these will cancel, and I'm left with -5. This is going to go to 0. When these will cancel, I'll be left with 7. So I'm left with -5 over 7, or y equals -5/7 is our horizontal asymptote. You could have also just taken the ratio of the leading coefficients since the degrees were equal. All right, now let's take a look at C. All right, let's try and find our limit. I'm going to go ahead and just divide right off the bat. I see the highest degree is x to the 4th. All right, well now I see that this is going to be 1 right here. This is going to be 0. It's going to be 0. This is going to be 0 because of the degrees. So I'm left with 1 over 0. This means the limit does not exist. So there is no horizontal asymptote. All right, this concludes video number 2, finding horizontal asymptotes the calculus way.